大家好，我们今天要讨论勾股定理。我今天要帮你们翻译这是什么东西。我们看数学的时候就要知道，很重要，很重要。所以我今天要跟你讲，啊？你说什么？今天不是 today? Wait, I thought we were talking about translations today. Oh, forgive me, class. We're talking about translations in geometry. Obviously, thought y'all wanted to hear my Mandarin. So, here we are. But, moving on. Let's talk about translations. A translation is something that slides the object to a new position. So when we are sliding these figures, they are congruent to the original figure, and the orientation does not change. So imagine you were doing the electric slide. You would just be moving to a new position, but you would still look exactly the same, and the direction you face doesn't change. So when we're talking about translations, we show that the translated point is the translated point by putting an apostrophe next to it. Just like in English you use apostrophes, we use them in math too. And these apostrophes are called primes. So for example, if we have the original point A and we translate it, the new point will be called A prime. There are two types of translations we'll be doing. One is a horizontal translation, where you move the point right, which means it's positive, or left, which means it's negative. And this affects the x value. Because remember, the x-axis is the horizontal axis. Then we also have vertical translations, where you move the point up, which again is positive, or down, which is negative. And that is the y value, because remember, the y-axis goes up and down. So every time we translate a point, a lot of times it'll give you a worded description, but you have to be able to translate that from English to Mathlish. So you go from x, y, and you write the algebraic representation. So whenever you are writing a new point in algebraic representation, it looks like x plus a, comma, y plus b. And this just shows the change that has happened to that point. So the x value is changed by a, and the y value is changed by b. So let's look at a couple of examples we have. Translating a figure in the coordinate plane. It says translate the triangle 3 units right and 5 units down. What are the coordinates of the original image and the new image? So first we can start with translating our new point and writing it in algebraic representation. So 3 units right is telling me that we're adding, and 5 units down tells me that we're subtracting. So this is adding to the x, and this is subtracting from the y. So we have x plus 3 and y minus 5. So let's go ahead and find the original points. We have j. So remember, when we read points, we go x-axis first and then y-axis. So we go right here. This is negative 1. And then 1, 2, 3. So negative 1, 3. K is negative 1, 1. And L is negative 4, 1. So we're going to translate this triangle 3 units to the right and 5 units down. So starting with J, we go 3 to the right, 1, 2, 3, and then 5 units down, 1, 2, 3, 4, 5. So we can label this new point J prime because it's been moved. Same thing with K, 3 to the right, 5 down, 1, 2, 3, 1, 2, 3, 4, 5. K prime. And then L. 1, 2, 3, 1, 2, 3, 4, 5. L prime. So if we connect these dots, we get a triangle. And even though my drawing isn't the greatest, it should look exactly congruent to this triangle. All we've done is we've moved it. We've slid it to the right and we've slid it down. So remember, the direction doesn't change. The orientation looks exactly the same. We literally just picked this whole thing up and moved it over here. So our new points. For J, we have 1, 2, and then down 2. So 2, negative 2. K, we have 2, negative 4. And L, we have negative 1, negative 4. So if you'll notice, on each of these points, the algebraic representation is what's changed it from the original to the translated. So our original J was negative 1, 3. So negative 1 plus 3 is 2. And 3 minus 5 is negative 2. So that's just what the algebraic representation is telling us, exactly where we moved each point and each value. So let's look at the second example. It said the vertices of a square are A, 1, negative 2, B, 3, negative 2, C, 3, negative 4, and D, 1, negative 4. Draw the figure and its image after a translation 4 units left and 6 units up. So 4 units to the left means we're subtracting, and 6 units up means we're adding. So this is subtracting from x, and this is adding to y. So our algebraic representation is x minus 4 and y plus 6. So let's start with our original figure. A is at 1, negative 2, so we go over 1 on the x-axis. If it helps, you need to label your axes. So 1, negative 2. That's A. B is 3, negative 2. B. C is 3, negative 4. C. And D is 1, negative 4. So we have this very small square right here. And we're moving it 4 units to the left and 6 units up. So let's start with point A. We're going 4 to the left. So 1, 2, 3, 4. And 6 units up. 1, 2, 3, 4, 5, 6. Here we have A prime. Same thing with B. 1, 2, 3, 4 to the left and 6 up. 1, 2, 3, 4, 5, 6. C, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And then D. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So, as you can see, when we connect all the dots together, we have exactly the same square, but it's been moved to the left and up. So our new coordinates, if we look at A prime, we have negative 3, 4. B prime, we have negative 1, 4. C prime, we have negative 1, 2. And D prime, we have negative 3, 2. So again, notice the relationship between the original and the translated. Each of these are changed by what the algebraic representation has told us. Example 3. So from here, we are given a picture, and from it, we have to figure out what the movement has been, both in words and then in algebraic representation. So we're starting with the red figure because it's A, B, and C, and the blue is A prime, B prime, and C prime. So we know that the blue is the figure that has been moved. So starting with this, let's look at, just pick one point and let's see what it has. So for A, from A to A prime, we go 1, 2, 3, 4. 4 spots over to the right, and then 1, 2, 3, 3 down. So move it 4, move each point 4 to the right, and 3 units down. That's 4 units to the right. So remember that when it's to the right, we know that it's positive, and we're talking about the x value. So our algebraic representation would be x plus 4. And for y, 3 units down would be negative, so y minus 3. And even though we just picked one point, it's going to be true for all of the points. So if you look from B to B prime, we go 1, 2, 3, 4, 4 to the right, and 1, 2, 3, 3 down. Same for C. 4 to the right, and 3 down. So that's why it's a translation. The whole figure is moved by the same number of units, either to the left or to the right, and up or down. So on your practice, we've gone through a bunch of different examples. You're going to have to be able to look at pictures and tell us the rules, or given a rule, be able to graph the pictures. So on your note sheet, you have an example 4, and you need to complete that in its entirety before we can do math workshop. Hope you have some fun sliding around.
Slide to the left, slide to the right, crisscross, crisscross, cha-cha, real smooth. Let's go to work.
Go to work.